this assertion lab's SVA, immediate assertions. Here in this design, we have a typical RISC-V FSM. It goes to the fetch, decode, and then executes cycles and or states. And we want to add a couple of assertions to check the right behavior. And in this solutions part, I want to show you that I can actually implement some of these as immediate assertions and show how they simulate in a typical simulator. RTL designer, we implement assertions inside the RTL as immediate asserts, and there's an always comp, and there's a unique case. Probably some of you are familiar with SystemVerilog RTL constructs. This actually has an implicit SVA that you will see in our simulation. And here are some of the assertions we added based on our understanding of SystemVerilog Assertions course on Udemy. This is the solutions for that. So we want to make sure when we are in the decode state, the opcodes are not unknown. That's $ is unknown, then reverse of it are negated. And then we also have a check for valid opcodes. These are the only opcodes we support at this stage. So that's one example. Then when we move on to the mem address section, we want to make sure the address bus does not contain unknown values X or Z's when you are in the correct state. Those are a couple of assertions that we want to test it out. Now let's go to the simulator and see how that actually plays out. Questa, if you will. So the first thing we do is vlib, as we all know. Then vlog is what we now use. The reference, which basically means the solution that I'm going to give you, and you see that there's a package and the .dat, and the package is imported, and you see this state machine test bench, and 0 warning, 0 error. That's a good thing. Then this is the top module. Now I'm going to simulate it using the vsim command, and I'm going to run the command line mode for now to say that we'll see how it goes. And you see that it's actually loading the design and the test bench. This is your .dat, this is your DB. Now let's run for 100 nanoseconds first. So when you see that there is a built-in assertion in the SystemVerilog RTL construct, what we used as unique case, if you remember. So since we used a unique case and none of the choices matched the value of an opcode at that point in time, and it's time 0 picoseconds, so most likely it's a noise, but nevertheless you get what is called a built-in assertion check. Let's run for some more time, and you're looking for this assertion failure. If you remember the theory during our Udemy SVA class, and by the way, if you haven't signed up for it, please go ahead and use the link provided here to sign up with discount for the course. And this is the lab 2, and you see that we already have an assertion coded as part of the solution, which is what is actually given to you as an exercise during the lab 2 to check for unknowns. And we check that the address shall not be unknown when we are in the specific state called the SMEM address. That kind of gives you a quick idea of what we are trying to capture in this FSM, in this RISC-V state machine to detect any unknown addresses at critical stages such as the decode. Right? It kind of completes this lab, and of course you could look at the waveform and debug it further, and all this is coming from you from CVC. Thank you.